I'm here to talk about DevOps culture and practices to create flow. And, a lot of the thinking that went into DevOps came from Lean. And so I'm going to spend a little bit of time talking about Lean. Toyota and the whole kind of idea of Lean and the Toyota production system is really based on this idea of the production line. So here you can see a picture. I think this is from Toyota UK. And you can see on the floor, there's these kind of lines that go all the way along the floor. And that's actually timing the length of time it takes the car to move along the production line. And what happens is, if that part of the process isn't done by the time the car gets to the end of the line, you can actually pull a cord called the and-on cord and stop the line and fix the problem. And so that's one of the many things that's kind of crazy about the Toyota production system is that, how often do you think the and-on cord gets pulled in a factory during a day? Anyone got any ideas? 100? Up. 3,000. 3,500 on average. That's a lot, right? That's unexpected. A lot of people think it's like a few times, a handful of times. 3,500 times a day on average that the and-on cord gets pulled to say there's a problem, we have to stop. And so that's just one of the many interesting things that's very counterintuitive about the Toyota production system and Lean. And so a lot of Lean thinking went into kind of the ideas of agile development and DevOps. And I just want to spend a bit of time exploring those. But, a lot of this Lean stuff came from the production line. Where's the production line? Right? This is our environment, and there is no obvious production line and and-on cord and markings on the floor here. So, where does that idea come from? There's lots of different ideas about, how the production line metaphor might apply. There's a guy called Charles Betts, very smart guy, who wrote a book called Architecture and Patterns for IT. He talks about how, basically the service portfolio is kind of like building the factory, and then what goes through the production line is actually the transaction. So as a user of a service, the production line is basically you requesting a transaction, like buying something or requesting a new user or something, and that transaction is the equivalent of the production line. There's also the idea of actually the product development process kind of being like a production line. So there's a fabulous book by Don Reinertsen called The Principles of Product Development and Flow, which is my favorite book about process. The other kind of idea about what the metaphorical equivalent of the production line might be in IT is this idea of a wall with tasks on it. So obviously, Kanban is a big deal. Kanban is a very powerful method for improving throughput in our field. And so the idea is, all these little sticky notes on a board represent tasks, things that are going through the production line, if you like. And what we try and do in Kanban, obviously, is manage work in process to try and improve throughput. But these aren't actually, these cards aren't actually things on a production line, right? They are, in fact, this is a representation of the work in the system. It's not the actual work in the system. So while it's true, this is very powerful and you can do amazing things with it, it's not, I don't think it's really the metaphor, a good metaphor for what the production line actually is. It only really is with the advent of the idea of infrastructure as code that you can get to something kind of more physical and tangible as an equivalent of the production line in IT. So this is my kind of big diagram of infrastructure as code that I made this morning, where basically you've got version control, and version control has everything you need to recreate your running production system. So I should be able, Martin Fowler has a test for your disaster recovery process, where he walks into your data center and takes a machine gun and a water pistol and basically blows everything up. And then he starts his stopwatch and times how long it's going to take you to restore service. And that sounds crazy until you realize that that's exactly what Amazon and Google and all these companies do. Jesse Robbins has a story about when he was master of disaster at Amazon, where he said, we've got a disaster recovery process. We haven't tested that. I'm going to walk into the data center, one of the data centers in a few months' time, and I'm going to turn it off. And everyone was like, haha, that's hilarious, Jesse. And he was like, no. I'm really going to do that. And he actually did it. And everyone was like, shit. But by all accounts, things pretty much worked. And that was fabulous, or at least no one's telling you anything else. And this is there's a group at Google who does disaster recovery testing, and they actually create these crazy scenarios like aliens invading Silicon Valley. That's actually a scenario they created, and they simulated what would happen, as this scenario unfolded over the course of a couple of days. And they do this every year. It's a big deal, and they do things like actually switching off the connection between Mountain View and the rest of the world, or actually switching off the cable that connects to the data centers in the Pacific region or whatever. So this idea that actually we should be able to restore service in a predictable, reliable way in deterministic time, that's a fundamental thing about the idea of infrastructure as code. And to be able to do that, we need to keep everything that we require to restore service in version control. So version control has your chef recipes, it has the code that you use to create packages, tests, all that other stuff, and the infrastructure you need to actually build that stuff. And we should be able to recreate running systems purely from version control. And the idea is that if you're doing this right, nobody's logging into those systems. Any changes you make to version control, and then you push them out to live. So here, actually, we have something which is a more interesting metaphor for production line. And so obviously, the reason I'm on stage is because I co-authored this book, Continuous Delivery. But the first kind of prototype of that was a paper that me and Dan North and Chris Reed wrote for Agile 2006, which was called The Deployment Production Line. And that was the original paper which talked about a lot of the ideas that went into the book. And the idea is that actually the stuff moving through the production line is code changes. And the production line is your process for taking code changes from version control into your production environment. Or, if you're building packages or embedded systems, those ultimately go out to users in the form of packages or actual physical devices. But the production line is what creates those things from version control. And so what moves through the production line is very tangible. It's code changes. As tangible as it gets in software development anyway. And so, I didn't invent this concept. I was just the guy who wrote the book. But it actually turned out, in retrospect, to be very, very powerful. One of the reasons why is actually hidden in the history of Toyota. So does anybody know what Toyota were doing before they made cars? What were they making? Textiles. Well, they weren't making textiles. What were they making? Machinery, right? Looms. So the first device that made Toyota famous, when they were called Toyota, which is the actual name of the family, was they made this thing called the automatic loom. So this is the Type G automatic loom, which at the time that it was created was the leading automatic loom in the world. And it was 20 times more productive than any other loom on the market at that time. And the reason it was 20 times more productive is because it was able to automatically detect any problems and stop itself. And so what that meant is you didn't have to have one person at every loom. You could suddenly have one person managing like a whole lot of looms, because what would happen is they would carry on going. If there was a problem, they would just stop. They would detect the problem and stop working, and then you could go over and fix the problem. And of course, that's very similar to this idea of the andon cord that then came to be in Toyota factories. So as a result of the fact that the loom stops itself when a problem arises, defective products can't be produced because the system will stop itself before producing defective textiles, which means that we have this massive increase in productivity. And so there's this phrase or this word in Japanese, although it's actually Chinese characters. So this word on the left is automation. So that's like robots, basically. And so the guy at Toyota, it was actually Sakichi Toyota. So Sakichi Toyota basically took that word that means automation and added, so that second character is the word for people. So that's a character that means people in Chinese and Japanese. And so automation plus people creates this word, which is often translated as autonomation, but it's basically just a modification of the word to add the radical for this character and produce this word on the right. So the word on the right is this concept of jidoka, which means automation plus people gets you systems which can kind of heal themselves and create products with 0 defects in them. So this is the concept that went into the automatic loom, the idea that the system doesn't know what to do, but it knows when something's wrong and it stops itself, and then people can come and intervene and fix the problem. And so this actually was very important in the whole development of lean philosophy, this idea of Jidoka, that we put a lot of automation in place to detect problems, and then we can detect them really quickly, and then humans could intervene and fix them. But actually detecting the problem and stopping as soon as possible is really crucial to creating high-quality systems and to a lot of the other benefits of lean, which is lower cost, higher happiness, and some of the other things that we're going to talk about later. And so this idea of visual controls, the ability to see something's wrong, I'm going to stop working, and we're going to fix the problem straight away, that is really central to lean philosophy. And again, that has actually a very powerful parallel in software development, which is continuous integration. This is actually the whole philosophy behind continuous integration. So who practices continuous integration on their team? So put your hands up. Keep your hands up. I'm going to kind of move here so I can see people. OK, so probably about a third of the audience. So keep your hands up. Keep them up. Keep them up. Put them down unless all the engineers on your team are checking into trunk at least once a day. If developers are checking into feature branches that don't get merged into trunk once a day, or they're not checking in once a day, most of the time, put your hands down. Otherwise, keep them up if people are checking into trunk to mainline at least once a day. OK, so I've lost about another third of the audience, maybe. So if every change doesn't result in the build being run and some kind of feedback from tests as to whether or not the thing you checked in actually worked, put your hands down. Otherwise, keep them up. All right, now, if the build goes red and it's not fixed within about 10 minutes, put your hands down. If the build is pretty much always fixed within 10 minutes of going red, keep your hands up. All right, so there's, gosh, about 10, 15 people in the audience who are actually doing continuous integration. So congratulations to those people. This is a serious point. Continuous integration is not running Jenkins on your feature branches and then ignoring the build when it goes red. My favorite paper on continuous integration is by a guy called James Shaw, and it's called Continuous Integration on $1 a Day. And it talks about how to do continuous integration with an old workstation and a rubber chicken and a bell. And this is how you do it. So basically, you've got your old workstation over here in the corner, and I'm on my machine, I write some code, and before I check it in, I run the build and make sure that it actually keeps the system working. So yay, run the build, goes green, I'm fabulous. So at this point, other people have been doing work, unless I'm a team of one, or I'm working at 3 a.m. or working at 8 a.m. maybe. And then I want to make sure my changes don't conflict with the changes that other people have been making. So I'm going to pull from trunk into my working copy. Or if you're using Git, you pull into your local repo, and then you do a merge. And then I run the build and tests again to make sure that the merge has worked, that my changes actually harmonize with the other changes that have been made. And then at that point, I'm ready to, if they go green, because I'm fabulous, I'm ready to share my code with everybody else. Because this is what version control is primarily about, right? Version control is primarily a sharing mechanism to share your work with other people so that other people can see what you're doing and give you feedback. So what I'm going to do, before I do that, is I'm going to walk over to the old workstation, and I'm going to see if the rubber chicken's there. And if the rubber chicken's not there, then I have to wait, because it means someone else is checking in. And then when it comes back, then it's my turn to check it. And so I take the rubber chicken, go over to my workstation, and at that point, I can push into trunk. So once I push into trunk, I go back to the old workstation, I check out tip or head, including my changes, and then I run the build and the tests again, and then hopefully it passes. If it passes, I put the rubber chicken down, ring the bell, ding, yay, I'm done. If the build doesn't pass, I don't get to ring the bell. And I've got two options at this point. I've got a few minutes where I can try and fix the build after making it red. So I maybe find the missing file that I forgot to check in. What's my other option? Revert, roll back it out. Absolutely right. If you have a bad change and it breaks the build, leaving that change red is one of the most selfish things you can do as an engineer. Because what that means is that everybody else is working off a version of the code that's not known to be good. That's equivalent to, the Loom says, I've got a problem, and you're like, fuck it. And keep going. Some shit's going to come out, whatever. Not cool, right? So back it out. Revert the change. All of Google. So obviously, the rubber chicken does not scale. Okay, let's be clear about this. However, what the process behind this does scale. So I actually forgot to put it on my slides, but Google has 10,000 engineers. All of Google pretty much is checked into one enormous Perforce repository. And they run thousands of CI builds a day within Google. So building off trunk, this process absolutely scales. It scales very, very effectively, much more than feature branches. But it's based on this idea that everyone is checking into trunk all the time, and we're getting fast feedback on whether the work we've all done collectively as a group is actually really working. So that's actually very powerful. And what it allows us to do is get quick feedback. Did I break something else? Did I introduce a regression? Did I introduce a performance problem? But continuous integration isn't enough. We need to go further than continuous integration. And so really, the concept of a deployment pipeline or a deployment production line is the extension of that all the way out to production. So, we have version control. We're making our changes into version control. That triggers build and unit tests running. We should get feedback from that in a few minutes. And if that breaks, that's like pulling the andon cord. That means no one else is allowed to check into version control until that problem is fixed. People can carry on working, but they're not going to be able to check into version control. We stop people checking into version control if the build's red. And then we fix that problem. But the tests that we can run in a few minutes are not comprehensive enough to give us confidence that we can actually release into production. Unless we're running some kind of Mickey Mouse system that isn't very big. We need to do automated acceptance tests, which might take hours or even days to run. We want to do performance tests. We want to do exploratory testing, usability testing. There's a whole bunch of other things we want to do to validate that our software is actually releasable. And so this is what the deployment pipeline does. It takes those things and strings them together. So after a build has passed the unit tests, we'll spin up an environment to do acceptance testing, and we'll run acceptance tests against that build. If that fails, again, we stop the line. We don't do any further work, or at least we fix that problem straight away. We prioritize getting that back to green as soon as possible. So if the acceptance tests break, not the tester's problem, everybody's problem. Someone makes fixing that their number one priority, and we get that fixed. Once there's a build that passes the automated acceptance test, that will go downstream for processes like maybe security testing, more comprehensive processes that take more time and resources and people. You don't want to waste humans' time on a build that hasn't passed a set of automated tests. And then ultimately, this is a very simple linear process. Your process will be more complex. It goes downstream to staging environments and ultimately to testing environments. And the idea is this: with continuous delivery, every change in version control results in a build, and a build not just of the software, but also of the environment within which the software exists, as much as possible. And every build is a release candidate. And the job of the deployment pipeline is to try and prove that that release candidate is not releasable. We can't prove that something's releasable. We can't prove the absence of defects. All we can prove is the absence of known defects. So we're trying to prove that the build is not releasable. And if we can't prove it's not releasable, we should feel totally confident releasing it. And if we don't, that means that our validations are not good enough. So the idea is every build is like a hero in an epic. And the hero, obviously, this is 2,000 years ago, so it's always a dude marrying a woman, right? So guy wants to marry the beautiful woman. Guy has to pass a series of tests, has to fight the evil monster, get a big pile of gold, and then have an emotional reunion with his father in the underworld. And then finally, after the emotional reunion, the hero gets to marry the beautiful woman. Yay! So this is software development, a bit less romantic, gets released to production, still kind of exciting. That's the idea of the deployment production line. It's like trying to challenge the build and prove that it's not releasable. So one of my favorite case studies of implementation of a deployment pipeline is by the HP LaserJet firmware team. And the reason I like it, first of all, is because it's firmware for a laser jet, right? So everyone's heard the Amazon and Facebook and all these other companies doing that. That's fabulous. Web systems, hooray. It's not as widely practiced as it should be, but at least we know it's kind of, in principle, possible. But firmware, that's kind of weird, right? So the reason they did this is because, it's the same reason that any company changes, is because it's really hosed and they've got no choice and their backs are up against the wall. So in 2008, the HP LaserJet firmware team were going way too slowly, and they tried a lot of other ways of trying to resolve their problems. And in the end, they were so desperate, they went to the engineering team and said, please help us to solve this problem, which is how you know things are really bad, when the marketing people start asking the engineers for help. And so the first thing they did, which is pretty smart and unusual, is to look at what people were spending their time doing. So 10% of their time was spent on code integration. They were spending 20% of their time on planning. Every time they released a new line of printers, they would make a branch in version control for that line of printers. So every line of printers had its own branch in version control. And what that meant is, anytime they put in a fix or add a new feature, they have to merge it between all the other branches. That was taking 25% of their time. They were then spending 25% of their time on current product support. What does that tell you, 25% of your time on product support? Quality problem. 15% of their time on manual testing. If you subtract that from 100%, what you're left with is 5%, which they claim to be spent actually building features or innovating in some way, other than what I would have been doing, which would have been sitting on the floor with a big bottle of whiskey. So they had this really terrible problem, and what they did was pretty radical. They basically said, we're going to re-architect the system from scratch, which is already a pretty scary and quite horrible idea. And it's going to take us about 18 months, 2 years to do that, and you're not going to get any product while we do that. And because the product people were so hosed, they basically had no choice but to let them do that, which is a sign of how bad things were. And what they did was they re-architected the system from scratch so they could do continuous integration. And what that meant was they had a single build of the software, no more branches, single trunk, single build of the software that would run on any of the devices. So firmware boots up. Oh, I'm a printer. Switch off all the features that are to do with scanners or network multifunction devices. Or firmware wakes up. Oh, I'm a scanner. So I'm going to turn off all these printer-related features. And so by basically putting feature toggles into the software, they could use one trunk and one build that ran on all the different possible devices. And then what they did is, over the course of a couple of years, they built this really amazing deployment pipeline, where basically every change, first of all, ran about 2 hours worth of tests in stage one. So you check into a Git queue, and then it builds what's in the Git queue and runs tests against it. Every developer has their own Git queue. And then if that passes, then all the changes get merged, and they run stage two, which is another 2 hours worth of tests. And if that build passes, then your change gets into trunk. So your change doesn't get into trunk unless it's merged with all the other changes that are waiting to get into trunk. And we've shown that 2 hours worth of automated tests pass. And at that point, it goes to level 2 testing, which is another 2 hours worth of automated tests that run on a virtual machine that the engineers built to simulate the actual logic boards that they were being run on. And then it goes to level 3, which is a simulator where they actually have racks of physical logic boards and run automated tests against the racks of physical logic boards. So I actually, when I consult, I carry around a copy of this book so I can spank people who say automated testing is too hard. Because these people did it for firmware by writing automated tests that run on logic boards. And if you can do automated testing that does that, no one else has a harder problem than that with automated tests that I know of. So spanking for the whiners. And then there's level 4 tests, which run, they have like 30,000 hours, 20 to 30,000 hours worth of automated tests. They run them in parallel on this huge grid, and they get feedback within 24 hours as to whether they've broken anything. So you know your quality within 24 hours. You get complete feedback on the quality of your software within 24 hours. And what that meant is that they never had a stabilization and integration phase at the end of their release anymore. That just goes away. You're always in a releasable state. And what that meant was that they were completely able to change the relationship with the product marketing people, because they used to build these huge product roadmaps, 12 months, and they would spend all this time planning. Now they didn't need to do that anymore, because if the product people change their mind, they can just stop what they're doing and start working on something else instead. So they traded off kind of certainty over hitting the roadmap, which they never hit anyway, because halfway through the product people would change their minds and they'd have to replan everything. So it was kind of delivering not very much value, to getting rid of that and being able to change their mind and change direction at any point. So it kind of had these huge roll-on impacts through the whole culture of the organization around what it meant to be good at software development and what it meant to be able to deliver products, which was that adaptability and being able to respond to market conditions is actually more important than certainty over something that probably won't get delivered in 12 months. That changed the whole economics of the process. So what that meant was we don't spend all this time on code integration. We spend much less time on planning. We spend much less time worrying about what's on the branches and moving code between different parts of the system. Product support goes down from 25% to 10% of the time. What does that tell you? Quality's gone up, right? So that's a good measure of quality. How much time do you spend on product support? Manual testing goes down from 15% to 5%, and they increase the amount of time they're spending on actually doing value-added work, in other words, work that customers will actually pay for, by a factor of 8. And the smart people in the audience will have noticed that the right-hand side doesn't add up to 100%. The other 23% of time on the right-hand side is spent on managing the automated tests. So there was a big investment to do that. This was incredibly expensive for them to invest in this capability, in test automation, configuration management. So one of the things they did was they locked down the workstations. Developers weren't allowed to control their workstations. They used configuration management to basically make sure that the workstations were locked down, so that if there's a problem in one of the test suites, they can, the system will email you a build, give you a list of all the test failures, and you can press a button and reproduce the test failures on a virtual machine that simulates the printer on your workstation. So it's a way to basically make it really easy for people to reproduce problems by just using configuration management to lock things down. And configuration management is really important to being able to do this stuff. And this, actually, the next slide, there's a typo, so I'm quickly going to fix that. Say hi to my daughters. Hi. So this actually reduces development costs by 40%, increases the amount of programs under development by 140%, decreases the cost per program down 78%, and then increases the amount of time that you're spending doing value-added work, stuff that's actually delivering value to customers, instead of non-value-added work, like merging stuff between branches and manual testing and so forth, by a factor of 8. So that's pretty huge. And this illustrates a key point about Lean. Lean is not about cutting costs. Lean is about investing to remove waste. And then when you remove waste, you increase throughput, and that is what leads to these results. And this concept of jidoka, being able to detect if there's a problem, stop what we're doing, fix the problem, is really essential to this capability and this economic transformation. And this is pretty cool, but I always like to show what Amazon's doing. So if you went to Velocity 2011, you might have seen this slide, which I just love to show because it's just amazing. They're deploying to production every 11.6 seconds. They're doing up to 1,079 deployments in an hour. On average, 10,000 boxes receiving a deployment, up to 30,000 boxes receiving a deployment. So that's kind of nuts, pretty amazing. The reason they did this is basically so they could innovate faster. And the way they innovate is by running a whole lot of A/B tests. And the point of doing A/B testing is kind of jidoka as well, because the point of doing A/B tests is to stop working on something that's not delivering value to your customers. Instead of building out a whole feature and deploying it, you build out an experiment, which is much cheaper to build, only covers 80% of the cases. You only roll it out to 1% of customers, so it doesn't have to scale. And then you find out if it actually moves the key metrics that you care about in terms of things like revenue or whatever you're measuring. And what they find based on, there's a guy called Ronnie Kahavi who built or helped to build Amazon's A/B testing framework and now works at Microsoft on Bing's A/B testing framework. He's got all this data that shows that of all the good feature ideas that they had, only about 1/3 of those ideas were actually successful at improving the key metric they cared about. So that's kind of terrifying. I mean, if you apply that generally, what that means is if you're not running experiments to test that the features you're building and the work that you're doing are actually delivering value, 2/3 of the work that you're doing is either delivering zero or negative value to your users. That means you could spend about 2/3 of your working week skiing or sitting at home drinking margaritas and deliver the same value to your customers. If only you knew the 2/3 of the work that you're doing that's delivering zero value to your customers. And not even that, 2/3 of the value-added work that you're doing turns out not to be value-added. So that all sounds fabulous. The question is, how do we get from A to B? And here's something else really cool, which is that the HP LaserJet firmware team also independently invented something called the improvement kata. So this is another bit of Toyota kind of lore. There's a guy called Mike Rother. What state is Ann Arbor in? Michigan. So he works at the University of Michigan. So he's a researcher. And his job was basically to go and research what Toyota did. And then other companies would hire him to tell them what Toyota did so that they could copy it. That was basically how he made money. And so what would happen is he'd then go back to the Toyota factories to see what they were doing 3 or 4 years later. And then he would notice that they're not doing those things anymore. And that was kind of embarrassing, right? Because he'd be like, Toyota are doing this. Maybe you should try that. And then they'd do that. And then he'd go back to Toyota and be like, oh, you're not doing that anymore. And that's kind of weird. They're not doing that anymore. Maybe you should try this, and et cetera. And so he quickly realized basically through a sense of guilt that he was misleading people, that what Toyota was actually doing was not important. What was important was how Toyota were working out what to do next. The capability to, the things that we describe as good practices or best practices, that's actually not a good term to use, because the practices that you actually see people doing who are successful are nothing more than countermeasures to the particular problems they're facing right now. And when that changes the environment and causes things to get better, they'll stop doing those things and work out what the next problem is and put in a countermeasure to try and fix that and keep going. So it's not the particular practices that you see people doing at any one time that are important. It's the process by which they evolve and change those practices, which is why the idea we're going to benchmark this company, harvest a bunch of good practices or best practices, and stick them over here, and that's going to work, is totally that doesn't work. Because you can't take something from one complex system and put it into another complex system and expect to achieve the same results. That just doesn't work. Which is why methodology adoptions are always a disaster. So what Mike Rother came up with is basically the mechanism by which Toyota does continuous improvement, which is the improvement kata. And it's a fabulous book. I highly recommend reading it. It's basically how management at Toyota works. And the job of the management at Toyota is basically to help the people who are doing the work out how to make things better. So the management's job isn't to tell people what to do, it's to create an environment in which people can safely experiment to try things out and make things better, and to basically set goals and set a direction and a vision that the people doing the work out how to achieve. So here are the steps. First of all, we understand the direction. So the direction for the HP LaserJet people, they wanted a 10 times productivity improvement, or 10 times increase in the amount of value-added work that was being done. That was their direction. They had 2 to 3 years, 10 times improvement in the amount of the proportion of time spent doing value-added work. And they only achieved 8 times, so they didn't achieve their goal, but it was still pretty cool. And so what you do then is you grasp the current condition. Where are we now? And then you set a target condition for about 2 to 6 weeks from now. So they did it every month, but 2 to 6 weeks is fine. So you say, what are the measurable outcomes we want to achieve a month from now? And then you do not plan how you're going to do that, because you don't know how you're going to do that. Because if you knew how you're going to do it, it wouldn't be innovation. Continuous improvement is about constantly innovating, getting better at what you do, and if you can plan that in advance, it's not really innovation, right? We've got all these smart people working for us. They're the people who are going to find out what to do, not the managers. So how you actually do it, and this cycle basically repeats from steps 2 to 4. That repeats like every month, or whatever you decide your interval is going to be. And then this thing on the right, PDCA, that's basically just running experiments. So every day, everyone comes into work and asks themselves, what's the target condition we're trying to achieve right now? Maybe we're trying to get 10 good builds a day out of our continuous integration system. That might be one of the target. That might be the target condition I'm personally trying to achieve. What's the actual condition now? Oh, the build's always red. What obstacles are preventing you from reaching it? Which one are you addressing now? What experiment can I design to try and move myself further towards that target? And then run the experiment. And then ask yourself, how soon can I go and learn from that experiment and see whether to carry on doing that or do something else instead? And this is a methodology not just for continuous improvement. You can use this for product development as well. So another of the things they do at Amazon is they've got these 2 pizza teams, and they basically say, this is the business metric we want you to care about. Here's roughly where we'd like it to be in a month from now. You go and work out how to do that. So they don't create epics and then break them down into, stories and then break them down to tasks and then feed them off to all the little teams and expect everything to kind of somehow work at the end, which it never does. But they just say, OK, here's a utility function you've got to maximize. Go and do that. And then the team works out what experiments they're going to run to try and do that. You can use the same thing for product development. You can use the same thing for continuous improvement. But fundamentally, it's about management and leadership creating an environment in which people can experiment, and it's safe to experiment and try things to get better. So HP did not build that deployment pipeline. They didn't have a plan to build this deployment pipeline, and then they split it up into a bunch of stories and spent 2 years doing it. That evolved over many, many months from a process of following the improvement kata. So every month they'd say, what do we care about in the next month? And they would set, these were they call them mini milestone objectives, but actually they were target conditions. So, animations. So they would have these target conditions, and they would say, our target condition for the next month, priority 1 issues open for less than 1 week. And then, for rank 1 is have our priority 1 change requests fixed, have our reliability error rate at the release criteria. And they had all these, they were basically measurable target conditions for the processes. And again, they didn't know how they were going to achieve this. They just said, OK, all the people on the teams, you work out how to do this. And this was at some significant scale. So there was 400 developers, by the way, on the HP LaserJet firmware team, distributed across 3 countries, working on a 10 million line code base and getting out of this system 10 builds a day, about 100,000 lines of code changed and checked into trunk every day. So it was a pretty serious operation. But this was the extent of the planning at the program level. Every month. They just set the target condition, and then people work out how to get there. So, and the other crucial thing about this is the metrics change every month. This idea that we have, here's the metrics we care about, and that's fixed for all time. That's not true. When you measure something, that changes the behavior of the people who are doing the work. And that may result in things that actually are unexpected. So, for example, we did some work for a company where the company specified 100% unit test coverage, and what happened is they got 100% unit test coverage, and all the unit tests called the method and then asserted true. So just telling people to measure something might not produce the results you expect, and that's why it's really important to go around and actually check and see what's happening on the ground and update the metrics accordingly. I only have a couple of minutes left. I just want to talk about a couple more things. One is, what do we measure? So actually, in the Toyota production system, they have these 5 things they care about. One is quality. What does quality mean for you? Is it how fast you can restore service if there's an outage? Is it the percentage of unplanned work that you're doing? Work out what quality means to you. Work out what cost means for you. What's the cost of making a change, of taking a change live? How can we drive down that cost? Delivery. How long does it take us to get a change into production? And then 2 that I think are really important. One is safety. So in the context of production line, safety has a meaning of not getting your arm cut off by a robot, for example. But in the context of building software and running systems, like how safe is it to do a deployment? How safe is it to make changes and run experiments? If something goes wrong, are we going to engage in an exercise where we find the person who's responsible and blame them? Or are we going to use blame-free post-mortems in order to try and improve the system and make it better? There's the idea of your safety as someone, the same things that create a safety culture are the same things that enable innovation as well. So making it safe to try things out and to run experiments and to do these things is really, really important. And then finally, morale. So it turns out me and Gene have been working with another configuration management vendor on doing a survey where we found out that actually job satisfaction is incredibly highly correlated with business outcomes. So actually, do you have scheduled downtime, which is on a Friday night between the hours of 6 o'clock and midnight? Do you have people, who here is performing deployments out of hours, like weekends or evenings? Who's doing that? Okay, that's well done, you people. That is a sign that something's wrong. That's bad. That's one of the first questions I go and ask when I go into a company is like, okay, do you have scheduled downtime? Is that scheduled downtime, does that include like 10 o'clock on a Friday night? That's a sign that something's wrong. That needs fixing. And a lot of the stuff in the continuous delivery book is about making that not be the case. So reducing the amount of time people are spending on their Friday nights doing work is actually an important metric. And really the key to all this stuff is creating, and this should be no surprise to anyone, a high trust culture. One of the other things we found was very highly correlated to business outcomes was which one of these cultures people worked in. So this is a guy who's talking about quality in health, about safety in healthcare. So how do you create safety in a healthcare context? And he came up with this typology of whether your organization is pathological or bureaucratic or generative. So pathological organizations, information is hidden, messengers are shot, responsibilities are shirked, bridging is discouraged, failure is covered up, and new ideas are crushed. Whereas on the right-hand side, you can see that for yourself, and you can work out where your organization lies in that. And actually, the important thing about this is the same generative culture that creates safety is the same generative culture that enables innovation. Because it has to be safe to fail. You have to make failure safe, in other words, not have horrible consequences in order to create a safe environment. That also has to be the case in order to innovate. We have to be able to run experiments and try things for innovation to happen. So, 4 takeaways. Jidoka. The purpose of automation is to find problems quickly so that human beings can work out what to do. That's the role of automation, not to try and fix everything. You can't have automation that fixes everything. You want automation to find problems quickly so that you can fix them quickly so you're not shipping stuff that's poor quality or even sending stuff that's poor quality to operations so they can spend hours and hours trying to get it to work. Work in small batches. Continuous delivery is about reducing the cost and the risk of making changes, so you can do it really, really often so you can work in small batches and get feedback. When you implement a system like this, or any kind of tool as part of a tool chain to help developers get their changes out, do not go off and build what Sasha Bates called a Rube Goldberg machine. That's very, very common. Work out everything you do when you build tools for developers or for anyone else should be connected to business outcomes that you care about. How can we measure those? How can we make sure that the work we're doing is going to produce a tangible business outcome in the next month? Always check yourself. Is the thing that I'm doing right now going to produce measurable outcome on my customers, and what's that going to be, and how am I going to find out if I've achieved it? And then the way to get better and do this stuff is through continuous improvement. And as Mike Roberts says, continuous is much more often than you think. Continuous improvement is not running a retrospective once a month. Continuous improvement is everyone, every day, trying to make things slightly better for everyone else around them. Which brings me to my final rule. So hopefully everyone knows this guy. This is Jesse Robbins, co-founder of Ops ex-master of disaster at Chef, volunteer firefighter in his spare time, and generally a massive overachiever. And Jesse's rule is my favorite rule, basically, about organizational change. Don't fight stupid, make more awesome. We don't have time for questions. Sorry about that. I'm around. These are my contact details. Stay in touch. Thank you very much. And hope you had a great conference. Thank you.